In this video, I'll go through the optimal pricing in the price discrimination game. So we'll begin with the case where there's no price discrimination, uniform pricing. So in the game, you're asked if you can only charge one price per item, independent of the buyer or the quantity, what price do you charge? So to answer this question, let P denote the price per unit. Now let's think about what prices could be optimal. So to think about this, let's scroll down to the demand curve here and take a look at it. So here we have the market demand curve, which we derived earlier. Now let's think about a price, say between 20 and 30, say 25. Could a price of 25 be optimal? Well, if the monopoly price is at 25, then it's going to sell one unit. But it could sell this one unit still at a higher price. So it could raise its price all the way up to 30. And it would still sell that one unit, but it would get a higher revenue and therefore a higher profit. So 25 cannot be the optimal price for one unit. So the best price to charge for one unit is 30. Similarly, if the monopoly wanted to sell 2 units, the best price to charge for 2 units would be 20. And then the best price to charge for 3 units would be 10. And we don't need to look at 4 units because selling that 4th unit would incur a loss. So the only quantities we need to think about are quantities of 1, 2, and 3, and the prices of 10, 20, and 30. So 10, 20, and 30 are our candidates for the optimal uniform price. So we see in the table, I have these 3 prices, 10, 20, and 30, the quantity demanded at each of these prices, and then I've calculated the profit. So for example, if the monopoly charges a price of 20, then it's going to get a profit of 30 because the price is 20, the cost per unit is 5, which means that the profit per unit is 15, and then we're selling 2 units, so the profit will be 30. And we can do this for the other prices. And all we have to do is compare these 3 profits, and you'll see that 30 indeed is the highest number of these 3, and so the monopoly will want to price at 20 and sell 2 units. So the optimal uniform price is 20 and the optimal quantity is 2. And then the maximum profit is 30. So I've shown this on the diagram below in the market demand curve, so we can see the optimal quantity, the optimal price, and then the profit is this rectangle here, the red and the blue areas. Now I've colored these different areas because one of these units is sold to buyer A and one is sold to buyer B. So buyer B, they will buy 1 unit at a price of 20, and this will be the profit from that unit, and this is on the diagram here. And then buyer A, similarly, we have this red area over here. And so those 2 areas add up to 30, each one is 15. Now what about the green area on this diagram? Well, this green area, that's consumer surplus, and that corresponds to this area up here. So buyer A is getting a consumer surplus at this price of 20 because they're willing to pay 30 for that first unit. Buyer B gets no consumer surplus because the price is 20 and the consumer is willing to pay up to 20 for that first unit. Now what about this area here? Well, this area is profit that the monopoly is not getting, which potentially it could if it were price discriminating. So this area is the deadweight loss under uniform pricing. So the total welfare here is the sum of these 3 areas, the green, the blue, and the red. They sum up to 40 because the profit here is 30 and the consumer surplus is 10. So that's uniform pricing. An alternative would be to find the marginal revenue and compare it to marginal cost and use that method to find the optimal price and quantity. Okay, so the next case you looked at in the game was first degree or perfect price discrimination. So in the game, you are asked, if you can fully price discriminate, tell which buyer is which and charge different prices for different quantities, what prices do you charge? Now, to answer this question, we are going to need 4 different prices. We need the price for buyer A for 1 unit, the price to buyer A for 2 units, and we need the price to buyer B for 1 unit and for 2 units. So the notation here, hopefully it's obvious. These are these 4 prices that I just explained. Now, to work out the optimal values of these prices, it helps to first think about how much should the monopoly sell to each buyer. So let's look at buyer A's demand curve here. Now, if we look at buyer A, does the monopoly want to sell 1 or 2 units to buyer A? Well, it definitely doesn't want to sell 2 units to buyer A because buyer A, their marginal valuation of the second unit is less than the marginal cost. So the monopoly would want to sell 1 unit to buyer A, and they would want to sell it to buyer A at exactly what buyer A is willing to pay, i.e. 20. So the optimal price to charge for 1 unit to buyer A is 20. Now, what price should the monopoly charge for 2 units for buyer A? Well, it just has to be a price such that buyer A prefers to buy 1 unit. So it has to be a price that will give A a negative surplus. So any price above 20, which is what buyer A is willing to pay in total for 2 units, the total area under this demand curve, would cause buyer A to get a negative surplus and therefore prefer to buy 1 unit at 20 and get a 0 surplus. Now, what about buyer B? Well, the idea is similar. Now, buyer B, their marginal valuation for the first unit is 30, which is more than marginal cost. So it makes sense for the monopoly to sell that unit to buyer B. But what about the second unit? Well, the marginal valuation of that, the height of this demand curve here, is also above marginal cost. So the monopoly can make a profit on that unit as well. So the monopoly will want to sell 2 units to buyer B. What price will they charge? Well, they'll just charge a price equal to the area under the whole demand curve, because that's the most that buyer B is willing to pay. Or if you go back to the table, they'll just charge buyer B their willingness to pay for 2 units. So the best price to charge for 2 units is £40. That's 30 plus 10. And what price should the monopoly charge for just 1 unit? Well, again, since the monopoly wants to sell 2 units, they should charge a price for 1 unit that makes it unattractive. So they could charge, £1 million. But the lowest price they could charge would be one that would give 0 surplus. They could charge a price equal to 30. And then buyer B would be indifferent between buying 1 or 2 units, and we would assume that they buy the 2. Now, we don't really care about the second price here, so instead of thinking about offering 2 different prices for each consumer, we could just think about offering a price and a quantity to each one. So to buyer A, we would offer the price quantity pair of £20 for 1 unit. So buyer B would have a choice between buying that or getting nothing. Now, because they get a 0 surplus from nothing and they get a 0 surplus from this option, they're indifferent and we assume they buy this option. We could always make them strictly prefer this option by lowering the price ever so slightly. Now, buyer B, it's similar. We'll charge them £40 for 2 units. They can either take that or leave it. They get 0 surplus from that option and also 0 surplus from the option of buying nothing. And so we assume that they choose to buy 2 units at £40. So under these price quantity pairs, what is the profit? Well, A is going to buy 1 unit for 20. This is going to mean a profit for the monopoly of 15, 20 minus the cost. So this is this first part here. And then buyer B, the profit from buyer B, well, he's selling 2 units at £40. The cost of 2 units is 10. So the profit from selling to buyer B is 30. So this is the calculation of that area there. So the total profit is 15 plus 30, which is 45. So this profit is higher than under uniform pricing. So if we go and now look at the market demand curve here, we'll see that the profit, which is made up of the blue and the red areas here, is actually now the whole area between the demand curve and the marginal cost curve. So the monopoly is going to be selling 3 units. Its profit is this whole area here. It's getting all of the potential surplus as profit, right? There's no way to increase the profit from here because to sell more units would require selling them below marginal cost. So the total profit and the total welfare are the same here. There's no consumer surplus. Both consumers are paying exactly what they're willing to pay for the amount they're buying. So this is why it's called perfect price discrimination. They can't do any better than this. So next is third degree price discrimination. So the question you asked here was, if you can tell which buyer is which but must charge a constant price per item, what prices do you charge? So here we're looking at each buyer separately and we're thinking, what price should we offer them per unit? So here we're going to call the price for buyer A PA and the price for buyer B PB. So we can proceed in the same way as we did under uniform pricing, except now instead of looking at the market demand, we look at the individual demand. So if we look at buyer A, what price should we charge per unit? Looking at the demand curve here on the left, well, we only want to sell 1 unit to buyer A and we'll sell it to them at 20. Now what about buyer B? Well, we compare the options of selling 1 or 2 units. Well, the profit from selling 1 unit, that's 30 minus 5, which is 25. If the monopoly wanted to sell 2 units, it would have to drop the price all the way down to 10, and then it would make a profit of 10 minus 5 equals 5 per unit, for a total profit of 10. So 10 is much less than 25, and therefore the monopoly want to charge a price to B of 30. So the maximum profit under third degree price discrimination is 15 plus 25, which is 40. Now if we look at the market demand curve, we'll see now these two areas. There's still some area here that the monopoly is giving up as profit, but it's doing better than it does under uniform pricing. So in particular, this area here, this rectangle, is no longer consumer surplus. Buyer B is now paying exactly what they're willing to pay for that first unit. So the monopoly is increasing their profit by this rectangle compared to uniform pricing. So this rectangle has an area of 10. So the profit under third degree price discrimination, which is 40, is 10 more than it was under uniform pricing. Now the last type of price discrimination you're asked to look at in the game is second degree price discrimination. So the question you were asked was, if you cannot tell which buyer is which but can charge different prices for different quantities, what prices do you charge? So now the monopoly is no longer able to offer different things to each consumer. They have to offer the same things to both consumers. So just as we did in the case of first degree price discrimination, instead of thinking about the question we're actually asked, we'll just think about what should the monopoly offer in terms of price quantity pairs. So because there are 2 consumers or 2 types of consumers, we only are going to need 2 price quantity pairs. So let's look at how we construct these price quantity pairs. To do this, it's helpful to think about what did the monopoly offer under first degree price discrimination. It offered 2 price quantity pairs. It offered one specifically to buyer A, and that was the price quantity pair of £20 for 1 unit. And it offered to B the price quantity pair of £40 for 2 units. Because the monopoly is no longer able to offer a different price quantity pair to each consumer, let's think about what happens if it offers these price quantity pairs and the 2 consumers can now choose which one they prefer. Which ones would they choose? Buyer A would still choose this option. And that's because if it were to choose the other option, it would get a negative surplus. So if you go back to the table, you'll see that buyer is only willing to pay 20 for 2 units, the same as what they're willing to pay for 1 unit. So buyer A will still choose the first option if they're given the choice of these 2 price quantity pairs. What about buyer B? Well, buyer B is willing to pay 30 for 1 unit, and therefore they would get a positive surplus from buying this option. They would get a surplus of 30 minus 20, or 10. But they get zero surplus from this one because they're willing to pay 40 for 2 units. So buyer B would actually prefer to buy this one. And so by offering these two options, the monopoly is going to sell just 2 of these price quantity pairs, and so they'll get a revenue of 2 times 20, which is 40, minus 2 times 5, which is 10, which is a profit of 30. But the monopoly can actually do better than this. So how can they do better? Well, they can do better by altering these price quantity pairs so that buyer A and buyer B buy different things. Now, the monopoly can't increase the price of this option to make it less attractive to buyer B, because then buyer A would not want to buy either option. In fact, we're going to leave this one as it is. You can't do any better than this. You can't change this to make it less attractive to buyer B. So instead, we're going to change this option to make it more attractive to buyer B. So to do that, we have to lower this price from 40. Now, because A is getting a consumer surplus of 30 minus 20, which is 10 from this option, we have to give them at least that much surplus from this option. So what we have to do is change the price in this second option. We have to decrease it so that buyer B would actually be indifferent between the two options. So we want to lower that price. How low should it go? Well, we want the consumer surplus of B, which is 40, which is their willingness to pay for 2 units, minus the price of 2 units, let's call it X, to be equal to the consumer surplus that A gets from the other option, which, remember, because they're willing to pay 30 and the price is 20, is going to be 10. So solving this equation, we need X to be equal to 40 minus 10, which is 30. So what we should do is reduce the price for 2 units to 30. And then buyer B will be indifferent, and we assume that they buy the one that the monopoly wants them to buy. If we didn't make that assumption, there would be no best price to charge. But you'll see if we lower this price a little bit, then buyer B would get a slightly higher surplus from buying the price quantity pair with 2 units than the price quantity pair with 1 unit. So this is all in the text here. So what we found is that the optimal price quantity pairs are these two here. So the monopoly should offer this menu of 2 price quantity pairs. It should offer a price quantity pair of £20 for 1 unit and the price quantity pair of £30 for 2 units. And then buyer A will pick the first option, buyer B will pick the second option, and the profit we can then calculate, it's 35. And this profit is higher than the profit it would have got if it kept the prices the same as under first degree price discrimination. If it kept those prices, it would just sell 2 of these first price quantity pairs and get a profit of 30. So here we have in the diagrams the profits and the consumer surpluses. So the profit from selling to buyer A is this red area, the profit from selling to buyer B is this blue area. They get some consumer surplus, remember that 10 that we had to give them, so that they would not prefer to buy the other option. So the difference between here, first degree price discrimination and second degree, is that the monopoly has to give up some surplus to the buyer with the higher valuation. So it can't get all of this here as profit, it's giving up this consumer surplus. In the lecture notes, we'll go through each of the 3 types of price discrimination, and we're going to be looking at the case where they have the smooth demand curves rather than these step shaped. But you should come back to these solutions and try and compare what we get for the smooth demand case to the step demand case here. And you'll see that things are similar. The only difference, I guess, is we'll have a smooth marginal revenue curve when we have a smooth demand curve. And so that makes the diagrams a bit nicer, though it makes the calculations harder. And that's why when we do calculations, we'll generally stick to the case where they can only buy whole units.